Hello friends, I welcome you in lecture number 9 on logic. In this lecture, we are going to talk about equivalence of two statement formulas, or we are going to talk about logical equivalences of statement formulas. So whenever we have two compound propositions, then they are called logically equivalent if they have the same truth values in all possible cases. That is, two compound propositions are logically equivalent if they have the same truth values in all possible cases. Suppose we have two propositions P and Q, then P and Q are logically equivalent is denoted by this notation. We will write this notation, or we will use this notation, and this means P and Q are logically equivalent. Some books are using this symbol also. We can denote that P and Q are logically equivalent using this symbol also. And one way to determine whether two propositions are logically equivalent is to use a truth table. So two propositions P and Q are logically equivalent if and only if the columns giving their truth values in the truth table are same, or the columns giving their truth values agree. We consider this example to understand that how we can use truth table to prove that two compound propositions are logically equivalent. Here we are asked to show that negation of P or Q and conjunction of negation of P and negation of Q, that we read as not P and not Q, are logically equivalent, and they can ask in this way also. Use a truth table to verify that these two are logically equivalent, and this law is called De Morgan's law. It is similar to the De Morgan's law in the case of sets. We know that if we have complement of union of two sets, then this is equal to intersection of complements. Complement of A union B is equal to A complement intersection B complement, and here you can see instead of union we have OR operation here, and we are taking negation of P or Q. Negation we can consider as complement. So negation of P or Q is equivalent to negation P and negation Q, or in the language of logic we can say that disjunction of P or Q is equivalent to the conjunction of not P and not Q. And sometimes they ask this type of questions on logical equivalence in GTU exams. This was asked in GTU summer 2022 exam. Similarly, we can have another De Morgan's law also. Here we have negation of P or Q is equivalent to negation P and negation Q, and we can write another equivalent De Morgan law by replacing this OR by AND 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 by OR. So let me write another form of De Morgan's law. Negation of P and Q is equivalent to negation P or negation Q. So in this lecture we are going to prove this De Morgan's law, and using this same method you can prove that this also is true, or you can show that these two are logically equivalent. So to prove this, first we are writing the columns required for truth table. Here we have two variables P and Q, and then what we will require on the left hand side, we will require P or Q. After that we will require negation of P or Q. On the right hand side we require negation P, negation Q, and then we will join them by this logical connective AND, negation P and negation Q. and these two are logically equivalent. Therefore the columns corresponding to this negation P or Q and this negation P and negation Q must be same, and that is the requirement. So first we write down the possible truth values for P and Q as we have discussed in earlier lectures. Possible truth values for P we write as T, T, F, F. For Q we consider alternately true and false, true and false. Now we find out P or Q. P or Q is true if either P is true or Q is true or both are true, or P or Q is false if both are false. So here in the last row both are false, therefore P or Q is false, and in all other cases we have at least one truth value as T, therefore we can write T here. Here we want to write down negation of P or Q. So if I have T here, I will write F, and if I have F here, I will write T. Here we want to write down negation of P, so that is going to be F, F, because I have T, T here, and then F, F, therefore this is T, T. This is for negation of Q. Here we start with T, so we have F here, then F, negation of F is T, T, then F, F, then T. And here we have to connect these two propositions by AND operator, and we know the definition of conjunction or AND operator. This is true if negation P and negation Q both are true, and it is false if at least one or both are false. So here in the first case both are false, therefore this is false. Here this is false, therefore this is false. Here negation Q is false, therefore we have truth value F here, and here in the last case both are true, therefore we have truth value T here. So now we have constructed the truth table, and now we observe these two columns. We can see that these two columns agree corresponding to these two compound propositions. Therefore we can say that these two compound propositions are logically equivalent. In notations we write in this way: negation of P or Q is equivalent to negation P and negation Q. So it is very easy to show that given two compound propositions are logically equivalent. We can use truth table in this way, and we can easily prove that two compound propositions are logically equivalent. Here they have asked another De Morgan's law, that negation of P and Q and negation P or negation Q are logically equivalent, and this was also asked in GTU summer 2022 exam. So as we did here, we can prove in this way. Instead of or here we have now and. In our case here we have and here we have or. That is second form of De Morgan's law, and that also we can quickly prove. If we wish, we can prove this also. Here we write PQ. On the left hand side we have P and Q and then negation of P and Q. So here we write P and Q. After that we require negation of P and Q, and then we require not P and not Q, and then not P or not Q. And now we try to construct the truth table. Possible values of P are T, T, F, F. Here we have T, F, T, F. Here we have AND operator. This is true when both are true, otherwise it is false. So it is false in all other cases. Here we have negation of P and Q. So true has negative false, then F has negative true. So that is the column for this. here negation of P, that is F, F, T, T. Negation of Q, so it starts with F and alternately false and true. Here we have OR operator between these two, and we know that this is true if at least one of these two is true, otherwise it is false. Here both are false, therefore we have F here. Here this is true, therefore this is true. Here also it is true. Here both are true, therefore this is true. And now we can observe the columns corresponding to these two compound propositions. You can see they agree, F, F, then 3 times T, here also 3 times T. Therefore we have proved another form of De Morgan's law, that is not P and Q is equivalent to not P or not Q. So sometimes they ask you to prove this type of logical equivalences, and here we remark this, that statement formulas P and Q are logically equivalent provided this biconditional is a tautology, and if this biconditional is a tautology, then P and Q are equivalent. This means what we proved just now, we proved that negation of P and Q is logically equivalent to negation P or negation Q. And this remark says that if these two are logically equivalent, then if we consider biconditional statement, that is negation P and Q, if and only if negation P or negation Q, then this biconditional statement is a tautology. If two statements are equivalent, logically equivalent, then if we construct the biconditional using these two compound propositions, then this compound proposition which is joined by this biconditional operator is a tautology. And reverse is also true. If this is a tautology, then these two are logically equivalent. So it is like this, that if this is a tautology, then these two are logically equivalent, or if these two are logically equivalent, then this becomes a tautology. In simple words, suppose I use one compound proposition is denoted by small a, another compound proposition is denoted by small b, then A and B are logically equivalent if and only if this biconditional is a tautology. So sometimes you can show that this biconditional is a tautology, and that also prove that two statements are logically equivalent. But we will use this method. We will find out columns corresponding to given compound propositions, and if those two columns agree in a truth table, then they are logically equivalent. But we will remember this remark that two propositions P and Q are logically equivalent. We can denote by these two different symbols, that is P and Q are logically equivalent if and only if this biconditional, that we can denote by this notation also, is a tautology. So this is all about logical equivalences. We will see some more problems on logical equivalence in upcoming lectures. Thanks for watching.